3.3 just adds one new element to this, and that is going from the math, going from the English to the math. So there's no additional theory in this one. In this section, it's just all word problems. I missed the line there. Speedy! The world's fastest slug requires at least 50 grams of sodium and 27 grams of sugar a day. So for part A, name and define variables. Well, go to the question. How many of each type of pill should Speedy take? Do we know how many of each type of pill Speedy should take? No. So what do you want to call the pills from bottle A? Sure. So X will be the number of pills from bottle A. Now, did anyone's arm fall off by writing number of pills? Hopefully not. Because it doesn't take that long to write number of. So don't say X is bottle A, that makes no sense. And what do you want to call the number of pills from bottle B? Y it is. Okay, D. Set up the corresponding linear programming problem. Let's start at the top. Are we trying to minimize or maximize cost? Minimize cost. So we're going to say min. Now as far as the letter you pick, you can pick whatever you want. You can say C for cost. The generic letter is Z. So you pick whatever. I'm going to use Z. You can also write minimize. We're trying to minimize cost. How much does each pill from bottle A cost? 16 cents. And how many pills from bottle A do we have? X. So the corresponding cost is 0.16x. Plus, how many pills, we have Y pills from bottle B. They each cost 45 cents. So the corresponding cost is 0.45Y. We're trying to minimize that objective function subject to. And we have a couple constraints. What do we have restrictions on? Well, that's going to come later. But let's talk about the functional constraints. What are the ones that directly come from the word problem?
2x plus 5y.
Tell me what they represent.
We need to get at least 50 grams of sodium and at least 27 grams of sugar.
Good. So we're going to have a restriction on how much sodium and how much sugar. Writing that down is optional. However, it's helpful because it reminds you to put all the sodium and all the sugar numbers together. So how much sodium is there from a pill from bottle A? 2 grams. And how many pills from bottle A do we have? Plus, how much sodium from a pill from bottle B? 5. And we have Y. And he needs at least, so that interprets as what inequality? Greater than or equal to. He needs at least 50. So put all the numbers that are similar categories together. 2, 5, 50 all relate to sodium. How about sugar? He needs at least how much sugar? 27. And then as Drew was saying, we cannot have a negative amount of pills. So X and Y are greater than or equal to 0. So that's how you set up your linear programming problem. What we're going to do is we're going to copy this and paste it to the next page. So now what we're going to do is we're going to graph it just like we did at the end of 3.2. Now, there will be no whining here. Yes, this axes go out to 36. It will not kill you to draw 36 tick marks if you had to on a project or a worksheet. So please get used to large graphs for certain problems. What's the x-intercept for our first one? And the y-intercept? 10. That sloppily says 2x plus 5y equals 50. Are we shading above or below this line? Above. 0, 0 makes it false. 0, 0 is below. So we're going to shade above. Remember, draw your line, test point, shade. Do not draw all the lines at once and then do your test points. It makes it a lot harder. What's the next x-intercept? 27. And the next y-intercept? 9. That's a 9 there. Notice we sort of have a squishy graph. What can you do? Nothing. We're going to shade above or below this line? Above. I'm just going to shade in the final answer here so I won't have to erase anything. So notice in both cases we have to shade above both lines. I should do that as a highlighter. I wonder if you can do highlighter over highlighter. How many corner points do we have? 3. Can you give me one of them? 0, 10. What's the other nice one? 27, 0. And then we have this one in here somewhere. So I'm going to erase our linear programming problem because we no longer need it. That's not a line. There we go. Oh, I see what it did. So we have 0, 10. I'll clean that up in a second. Fine, I'll just make that the 10. We have 27, 0. So if you would, go through and find your third point. This last corner point is 15, 4. Okay, we're going to put these 3 ordered pairs into the objective function z equals 0.16. X plus 0.45 y. Before we do, let's talk about things. If you recall from the problem, if you notice, the pills from bottle A contain less of those supplements than the pills from bottle B. And that's also corresponding in the price. Pills from bottle A cost less than the pills from bottle B. So if money wasn't an object, then he should just load up on pills from bottle B, because he'll quickly get his supplement restrictions there. But since money is an object, we have to take into consideration the cost of those pills. So the whole point of linear programming is to figure out an optimal solution that satisfies those restrictions, but at the same time, in this case, minimizes cost. If cost, again, wasn't an object, or resources weren't objects, where you have as much as you want, then we wouldn't be doing these types of problems. So if we put in 0 in for x and 10 in for y, what do we get? Yeah. If we put in 27 in for x and 0 in for y. 2.72. Did anyone else get that? 4.32? Yeah. Good. And 15 in for x and 4 in for y. 4.2. Thank you. Okay. So since we're trying to minimize cost, we'll pick the last one, 15.4. But what's the interpretation?
15 bill A and 4 file B would be the lowest cost
Of
bills.
what is the lowest cost? $4.20. So Speedy should take 15 pills from bottle A, 4 pills from bottle B, and he'll spend $4.20. That's what you get to write in a sentence format. 15 pills from bottle A, 4 pills from bottle B, and he'll spend $4.20. So again, the only difference between 3.2 and 3.3 is going from the words to the problem. Other than that, it's pretty much the same thing.